Morning all of you. This is K. Yashwant from CSC Data Science Section B. Now I am presenting the topic of about the evolution of wireless sensor based healthcare in the regarding of subject database management systems. So now we go through the introduction and exploring of in this presentation the evolution of wireless sensor based healthcare from micro to nano. Here from micro to nano, the evolution of wireless sensor based healthcare. Introduction to wireless sensor based healthcare. Wireless sensors have revolutionized patient monitoring and health management. The evolution from micro to nano sensors reflects technological advancements. This presentation explores the journey and future prospects of sensor technology in healthcare. So, first we go through introduction. Wireless sensors have the revolutionized patient monitoring and health management. This evolution from micro to nano sensors reflects the technological advancements. In this presentation, explores the journey and future prospect of sensor technology in healthcare. Early microsensors in healthcare. Microsensors emerged as compact devices for real-time health data collection. They enabled continuous monitoring of vital signs like heart rate and temperature. Early microsensors improved patient outcomes through better data accuracy. Here, microsensors emerged as a compact devices for the real-time health data collection. They enabled the continuous monitoring of vital signs like heart rate and temperature. Early microsensors improved patient outcomes through better data accuracy. Limitations of microsensors. Microsensors still faced challenges related to size, power consumption, and biocompatibility. Their limited miniaturization restricted integration into some medical application. These limitations spurred research into even small sensing technologies. So we have some limitations of microsensors. Mic, uh, Microsensors still face challenges related to size and power consumption and biocompatibility. Here, microsensors are in very small size and it can face the power consumption challenges and also biocompatibility also. Their limited miniaturization restricted integration into some medical application. So these limitations spurred the research into even small sensing technologies. Next, the shift toward nanosensors. Why the microsensors are shifted into the nanosensors? Nanosensors operate at the molecular or atomic level, providing of unprecedented sensitivity. They enable detection of biomarkers and pathogens with high specificity. And the move towards nanosensors aims to create less invasive and more precise healthcare tools. Here, nanosensors can operate the molecular or atomic level, providing the unprecedented sensitivity. They enable detection of biomarkers and pathogens. The move towards nanosensors aims to create less invasive and more precise healthcare tools. Advantages. So, what are the advantages of nanoscalar sensors? Nano sensors offer enhanced sensitivity and faster response times. Their small size allows for integration into wearable and implantable devices. They facilitate early diagnosis and personalized treatment strategies. Here, there are some of advantages. What are the advantages? Nanosensors can offer the enhanced sensitivity and faster response times. Their small size allows for integration into wearable and implantable devices. They facilitate early diagnosis and personalized treatment strategies. So these are advantages of nanoscaler. So what are the technologies enabling the nanosensors? Advances in nanometers like graphene, carbon nanotubes, and quantum dots are key. Microfabrication techniques enable the production of complex nano sensor architectures. Integrations with wireless communication modules allow real-time data transmission. Here, there are some of technologies. First, advances in nanomaterials like graphene, carbon nanotubes, and quantum dots are keys. Next, microfabrication techniques enables the production of complex nano sensor architectures. Integration with wireless communication modules allows the real-time data transmission. Wireless communication in sensor networks. So, what are the wireless sensors? Wireless sensors are communicate data to central systems for analysis and storage. Technologies like Bluetooth, Wi-Fi, and 5G support high-speed, low-power data transfer. Wireless connectivity enhances mobility and continuous health monitoring. So, these are some of wireless communications in the sensor networks. Here in wireless communication, we have used the technologies like Bluetooth, Wi-Fi, 5G support. So these are some of technologies. So these are called as sensor networks. Wireless communication. So here we didn't use any other wise for these technologies. So here also we have implementing a from nano to micro to nano a healthcare system by the wireless. Wearable health devices. Wearables incorporate micro and nano sensors for monitoring vital signs. They enable remote patient monitoring, reducing of hospital visits. Advances include smartwatches, fitness bands, and patch sensors. Implantable sensors and devices. Implantable sensors provide direct access to internal physiological data. They are used for cardiac monitoring, drug delivery, and glucose sensing. Miniaturization to nanocycle reduces insavviness and improves the patient comfort. Here, implantable sensors provides the direct access to internal physiological development data, and they are used for the cardiac monitoring, drug delivery, and glucose sensing. And miniaturization to nanoscale reduces the invasiveness and improves patient comfort. So implantive sensors. In implantive sensor, we have used that cardiac monitoring by the monitoring of heart and cardiac. Next, drug delivery and the glucose sensing. So these are three used for implantable sensors. Challenges. So what are the challenges in nano sensor development? Fabrication at nanoscale requires precise and cost-effective manufacturing process. Ensuring biocompatibility and avoiding of immune response remains critical. Powering of nanosensors is challenging due to limited space for batteries or energy harvesters. Here, fabrication at the nanoscale requires a precise and cost-effective manufacturing process. Ensuring biocompatibility and avoiding of immune responses remains critical, and powering of nanosensors is also challenging due to of limited space for batteries or energy harvesters. Power solutions. So what are the power solutions for nanosensors? Nanosensors power solutions are energy harvesting techniques like uh, piezoelectric and thermoelectric methods are promising, and wireless power transfer can sustain nanosensors over extended periods. Developing low power electronics is essential for long term operation. So energy harvesting techniques like piezoelectric and thermoelectric. So these are two methods for energy harvesting techniques, and wireless power transfer can sustain nanosensors over extended periods, and developing of low power electronics is essential for the long term operation. Data management. So what is data management and security? Here, large volumes of data from wireless sensors requires robust storage and analysis systems. Ensuring of data privacy and security is vital for patient trust and compliance. Blockchain and encryption technologies are increasingly used to safeguard health data. So, data management and security. In data management and security, so, large volumes of data from wireless sensors requires robust storage and analysis system. Ensures data privacy and security is vital for patient trust and compliance. Blockchain and encryption technologies are increasingly used to safeguard health data. Future trends in wireless sensor healthcare. Integration of AI and machine learning will enhance data interpretation and decision making. Development of fully autonomous nano sensor systems is one on the horizon. Personalized medicine will benefit from continuous real-time health data. Here, integration of AI and machine learning will enhance data interpretation and decision making, and development of fully autonomous nano sensor systems is on the horizon. Personalized medicine will benefit from continuous real-time health data. Ethical and regulatory considerations. Ensuring of patient safety and data privacy remains a primary concern. Regulatory bodies are developing standards for nanosensor approval and use. Ethical deployment involves addressing issues of consent and data ownership. Here we have ethical and regulatory considerations. Ensuring of patient safety and data privacy remains a primary concern. Regulatory bodies are developing standards for nanosensor approval and use. Ethical deployment involves addressing issues of consent data and ownership. Impact. What is the impact on healthcare systems? Wireless sensors can lower healthcare costs through early detection and prevention. They enable decentralized healthcare, bringing services closer to patients, and widespread adoption can improve health outcomes and quality of life globally. So here Wireless sensors can lower healthcare costs through early detection and prevention. They can enable the decentralized healthcare, bringing services closer to the patients. And widespread adoption can improve the health outcomes and quality of life globally. Case studies. So, what are the case studies and application about that healthcare model? Continuous glucose monitors exemplify nanosensor integration in diabetes management, and wearable cardiac sensors provide early detection of arrhythmias, and remote monitoring of elderly patients enhance independence and safety. First, continuous glucose monitors. Glucose monitors can exemplify nanosensor integrations in diabetes. In diabetes, we use the glucose monitors. In cardiac sensors, it can provide early detection of arrhythmias, and remote monitoring can be enhance the independence and safety of elderly patients. Challenges and opportunities. Overcoming technical and manufacturing barriers is essential for widespread adoption. Collaborative efforts between engineers and clinicians and regulators are vital. The future of wireless sensor healthcare is promising with ongoing innovations. Conclusion. So finally, we concluded that evolution of from micro to nano sensors marks a significant milestone in healthcare technology. Advances in miniaturization and wireless communication continue to transform patient care. Ongoing research and ethical considerations will shape the future landscape of wireless sensor healthcare. References and further reading. A curated list of key scientific articles, reviews, and industry reports, and recommendations for staying updated on innovations in sensor technology and healthcare, and encouragement to explore interdisciplinary approaches for future development. So, for the further reading and references, we have to a curated list of key scientific articles, reviews, and industry reports, and recommendations for staying of updated innovations in sensor technology, and also encouragement of explore interdisciplinary approaches for future developments. So thank you for giving this an opportunity for the describing about the topic of from micro to nano healthcare system in DBMS. Thank you.